Hello friends, myself Rajendra Mahajan presenting my video on partial differentiation, a revision series. First video, basic concepts of partial differentiation. Uh, this video is divided in three parts. First part is about the difference between ordinary differentiation and partial differentiation, and second, rules for partial differentiation, and in third part, examples on that rules. Let us see the basic difference between ordinary differentiation and partial differentiation. For that, consider y is equal to function of x, y as dependent variable and x as independent variable. Whenever we have such type of function of only one independent variable, then whatever the derivatives we are obtaining, that derivative is called as ordinary derivative. This is the known to all of you, and it is denoted by dy by dx. This is the first. One. Second type is when we have a function of two or more than two independent variables, like z as function of x and y. X and y are two independent variable, then we can differentiate z with respect to x, keeping y constant, is called as partial derivative of z with respect to x, and it is denoted by the symbol dou z by dou x, keeping y constant, or simply we can write it as dou z by dou x, or we can differentiate z with respect to y, keeping x constant, to get partial derivative of z with respect to y. Therefore, this is the basic difference between these two types of derivatives, ordinary and partial. Once again, I quickly repeat the same thing. If we have a function of one independent variable, then whatever the derivatives we are finding or we are obtaining is known as ordinary type of derivative. And second, when we have a function of more than one independent variable, 2, 3 like this, then the derivative is called as a partial derivative. This is the basic difference between ordinary and partial differentiation. Therefore, watch the video up to end for better understanding, clear understanding. And if you like it, please share it as well as subscribe to my channel. This type of derivative is called as partial derivative. Already I have mentioned it. Then, in second part, we try to see the rules of ordinary as well as partial derivative. Let us discuss one simple example of partial differentiation. Consider example from physics. P into V is equals to nRT, where P stands for pressure, V stands for volume, N and R are constant terms, and T stands for temperature. Then if we solve it for P, we get it is nRT divided by V, nothing but it is function of t and v. Then we can differentiate that p with respect to t keeping volume constant, that is called as a partial derivative of p with respect to t keeping volume constant. Or we can differentiate that p with respect to volume keeping temperature constant. This is the another example of that partial derivative. Therefore, with the help of this, we can explain the example from day-to-day life or from physics. Then, after knowing what is by partial derivative or how we can obtain the partial derivative of the given function, in second part, we discuss the rules of partial differentiation. Whatever the rules we are using to obtain ordinary differentiation, all that rules are applied as it is to obtain partial differentiation or partial derivative. We see one by one. D by dx of k into x. K stands for constant. It is nothing but constant term we take outside, and then differentiating x with respect to x, we get k into derivative of x with respect to x is 1, and therefore it is k into 1, nothing but k as a derivative. Similarly, for partial derivative, we consider dou by dou x of, example is 2x into y. We have to differentiate this term with respect to x. At that time, we have to consider y as a constant term. Therefore, 2 and y we take as a constant term outside, and then differentiating the remaining term with respect to x. Therefore, we get 2y, and derivative of x with respect to x is 1. Therefore, partial derivative of 2xy is 2y as per the first rule. Then second rule, dou by dou x of sum of the two functions f of x and g of x. We have a differentiation of first one is f dash of x, and differentiation of second term is g dash of x. Then differentiating partially for the given function z as u of xy, function of two independent variable, and v, function of two independent variable. Therefore, exactly using the same rule, we can obtain dou z by dou x as differentiation of u with respect to x keeping y constant, and derivative of v with respect to x keeping y constant. Then third rule as a product rule. U into v as a function, and we have to differentiate it with respect to x. Using product rule, we get first term u, derivative of second term as dv by dx, plus second term v, and derivative of first term as du by dx. This is called as a product rule or UV rule, and then same is applicable for partial differentiation also. For that, we consider z as a product of u and v, where both u and v are function of two independent variable x and y. Then we can differentiate z with respect to x, that is nothing but dou z by dou x, by applying product rule. First term as it is u, derivative of v, it is dou v by dou x keeping y constant, plus second term v, and derivative of u with respect to x, keeping y constant. Therefore, this is known as the product rule. And the last rule is quotient rule. Y is equal to u by v, where u and v both are functions of x. Then dy by dx is v, derivative of u as du by dx, minus u and derivative of v with respect to x, divided by v square, known as the quotient rule. And the same we can use to find the partial derivative of z when z is given as u function of xy divided by v, again a function of x and y. Then dou z by dou x is equals to v, derivative of u, dou u by dou x, minus u, derivative of v, dou v by dou x, and divided by v square. Therefore, all that four rules are applicable as it is. Then, example based on above rules. As a third part, first simple example, u is equal to 3x square into y. Then obtain or find dou u by dou x and dou u by dou y. Partial derivative of u with respect to x and partial derivative of u with respect to y. Here, u is a function of two independent variable x and y. Differentiating it with respect to x, keeping y constant. When we take y constant, 3 and y we take outside, and derivative of x square is 2x. Therefore, the term is 6xy as the value of dou u by dou x. Then differentiating u with respect to y, keeping x constant. Therefore, dou u by dou y is equals to, we get 3 constant term outside, x square also constant term outside, and derivative of y with respect to y is 1. We get value as 3x square. Then z is equals to, second example, a sum of two terms, 2xy, and second one is 3 e raised to x into y square. Two terms, both are functions of x and y. Then find dou z by dou y and dou z by dou x, and dou 2z by dou x square, second order derivative, and lastly dou 2z by dou y square. Four derivatives we have to obtain. Therefore, differentiating first z with respect to x, keeping y constant. Therefore, differentiating first term with respect to x by taking constant term outside. That constant terms are 2 and y, we take outside, and differentiation of second term with respect to x. Therefore, it is dou by dou x of first term 2xy and dou by dou x of second term, means differentiating individually first and second term. Then applying that rule, constant term we take outside, therefore 2y constant outside, and derivative of x with respect to x is 1. In second term, 3 and y square are constant term outside, and derivative of e raised to x with respect to x is e raised to x. Then differentiation of z with respect to y, keeping x constant, we get dou by dou y of first term 2xy and dou by dou y of 3x into y square. Applying the rule, constant term we take outside, therefore 2 and x are constant term we take outside, and differentiation of y with respect to y is 1. Then in second term, 3 and e raised to x is constant term outside, and derivative of y square with respect to y is 2y as the value of dou z by dou y. Then dou 2z by dou x square, second order derivative of z with respect to x. For that we have to differentiate dou z by dou x again with respect to x. Therefore, it is dou by dou x of value of dou z by dou x from equation 1. It is 2y plus 3 e raised to x into y square. Therefore, first term it is constant term, derivative of that constant term is 0. In second term, constant terms are 3y square, we take outside, and derivative of e raised to x with respect to x is e raised to x. Therefore, value is 3y square into e raised to x. Equation number 3rd. Then dou 2z by dou y square. For that, we have to differentiate dou z by dou y again with respect to y. Nothing but dou by dou y of, this is called as the operator of differentiation, dou by dou y. And dou z by dou y is 2x plus 6y e raised to x. Therefore, differentiating first term with respect to y, as it is constant term, its derivative 0. Derivative of second term, constant terms are 6n e raised to x outside, and derivative of y with respect to y is 1, and therefore we get the value as 6 into e raised to x. Third example for the product rule. It is a product of e raised to xy, first term, into another function 2x y square. Therefore, here it is a product of two terms of xy. Therefore, to find dou z by dou x, we have to apply that product rule. Therefore, we get dou z by dou y, dou z by dou x, keeping y constant and applying product rule. First term e raised to xy, and derivative of second term with respect to x is 2y square. Plus second term as it is 2xy square, and derivative of e raised to xy is e raised to xy and into y, and therefore we get e raised to xy 2y square into 1 plus 2xy square e raised to xy multiplied by y. From this two term we can take y into e raised to xy into 2 as a common term. Therefore, 2y square and e raised to xy common. Remaining terms are in the first term we get 1 as a remaining, and from second term we get xy. Then lastly, example for a quotient rule. If u is equal to, we have e raised to x plus y, that term is e raised to x plus y divided by e raised to x plus e raised to y. Both terms, numerator and denominator, are function of x and y. Then differentiate u partially with respect to y, keeping x constant. And therefore, to obtain that dou u by dou y, we have to apply quotient rule. We get dou u by dou y is equals to dou u by dou y is equals to denominator term as it is means it is e raised to x plus e raised to y. It is e raised to x plus e raised to y into a differentiation of e raised to x plus y with respect to x. Oh, sorry, it is with respect to y. Therefore, dou by dou y of e raised to x plus y. Then minus a numerator term as it is e raised to x plus y and differentiation of denominator term with respect to y, that is dou by dou y of e raised to x plus e raised to y, and whole divided by v square means here e raised to x plus e raised to y whole square. Then performing the differentiation we get e raised to x plus e raised to y, that term as it is, and derivative of e raised to x plus y with respect to y keeping x constant is e raised to x plus y as it is. Applying chain rule, differentiation of x plus y with respect to y is 1 minus e raised to x plus y as it is, and differentiation of that two terms with respect to y, derivative of first term is 0 and derivative of second term is e raised to y, and whole divided by e raised to x plus e raised to y whole square. Further simplified as we can take e raised to x plus y as a common. Remaining terms are e raised to x plus e raised to y and minus e raised to y, and whole divided by e raised to x plus e raised to y whole square. E raised to y get cancelled. We get final answer as e raised to x multiplied by e raised to x plus y whole divided by e raised to x plus e raised to y bracket square as the required answer. Therefore, like this I have discussed simple examples on the rules. Please like my video, share it, as well as subscribe to my channel, and to receive the notification please press the bell icon. Thank you. Thanks for watching. Then see you in next video.